Okay, let's talk about a subject that's near and dear to our hearts: cafe racers. It may not be technically a cafe racer, probably more of a true production racer. This is my 64 Thruxtonized Bonneville, and by Thruxtonized it means that it has a lot of the components from, matching the true Triumph Thruxton racers of the mid and late 60s. This is a bike that I've, believe it or not, been working on for more than 20 years. Hate to say, it's kind of hard to believe, but I've finally got it to a point here where we're getting close to firing it up. But anyway, getting back to cafe racers, a cafe racer is really a street version of a true factory racer or a production racer. But generally, cafe racers have to be streetable, because that's the whole concept. You're racing from cafe stop to cafe. There's a few attributes of a cafe racer that you'll see here on the Bonneville, and it kind of starts, I think, with the low bars. You're going to tend to have low bars or clip-ons. Clip-ons more aggressive, harder on your back, but a little bit more tucked in from the wind. Cafe racers are going to tend to have a larger tank, like this one, this being a true home market 4-gallon Triumph tank. Very rare here in the States, but they were on many of the Thruxtons. But you're going to tend to see a 3, 4, even 5-gallon tank on a cafe racer. Another thing you're going to see is rear sets. You're going to see a few little areas here not quite back together on this bike, but the rear sets are here. You're going to tend to have those on cafe racers. Get your feet back, shift your weight forward, shift your weight onto the front wheel more. Again, just more aggressive. You're going to tend to have, on a cafe racer, you're going to tend to have a solo seat or a single seat. Not necessarily designed for going 2 up. You probably could do it, but it might not be too much fun. You're going to tend to have a swept-backed exhaust. You're going to tend to have some type of more performance-oriented exhaust, like these beautiful Thruxton mufflers. Certainly Gold Star. Any kind of megaphone type exhaust will do. Another feature you'll see on a lot of cafe racers is, alloy or Barani Acront wheels. They look cool. They're a little bit lighter probably than steel. Probably a little bit more rigid, but the main thing is they look cool. So you're going to have that. These are just some of the features you're going to find on a lot of cafe racers. Let's go around to the front here, where you're going to see an original Avon fairing. Fairings are not required for cafe racers, but they do take off a little bit of the wind, a little bit of aerodynamic performance. These again are parts that I've been accumulating for more than 20 years. You may see cool levers, grips. These are some original Tomaselli levers that I got long ago. Another thing you're going to see on production racers is generally, on cafe racers, is generally something done with the front brake. This one has an original Triumph type twin leading shoe front brake, common on Triumphs and BSAs. This one has an air scoop, which I fabricated a while back. Also, again, a Barani front wheel. These are all generally features of cafe racers. There's not a rigid formula, and the goal here is to have fun. So another thing that I went to a great amount of trouble on this bike is having a true close ratio gearbox. Close ratio gears are much better on the track because it allows the engine to sort of stay on the cam more often in the proper rev range. But for the street, they can be tricky. We'll see. This bike also has some Dunlop rubber-mounted carbs, monoblocks in this case. But again, all of these are features you'll find on cafe racers. Don't have to have all of them. They're all different, and they're all subject to whatever budget you may have. And again, the idea is to have fun, emulate your heroes, get some track performance on the street, and hopefully it's not too far that it's not rideable. Next, let's get into the fabrication of a frame jig for a cafe racer. In an attempt to get everything as square as possible, I'm using this square tool from Fireball tool I've had for many years. And the beauty of it is it has spaces, slots, where you can slide the tip of a clamp in and tighten the square up against the metal easily and on both sides. It just gives you a known 90-degree reference point to pull everything together and keep it as accurate as possible. Okay. So much of welding is about controlling distortion. The heat, once you apply heat to the steel, it immediately starts to move and bend and distort. So anytime you're attempting to weld something, you have to control the distortion. And a lot of that's done by simply controlling the heat. We can, get more into this as we go along here. I tend to use silicon bronze filler and what's called TIG brazing, or TIG welding with silicon bronze, as it allows me to use a lower temperature to make the joint. It's not necessary to do this on a frame jig, but I do it just to keep practicing with how it goes together. It's just a way to continue to practice. We'll get more into this, but on any motorcycle or automotive application, you really don't want to embrittle the steel by applying too much heat. So this is something we have to constantly think about. And we have to always resharpen our tungsten. I like this motorized diamond wheel tungsten sharpener, and there's many different ways to do it. The most important thing is that however you sharpen your tungsten, be sure that whatever you're using is only used on tungsten and nothing else. In other words, you don't want to contaminate the wheel or the grinder that you're using with anything other than tungsten. Not bad. Okay, so let's take a look at this side. I've done a few frame jigs over the years, mostly for big V-twin type Harley style bikes, and those tend to have a single top tube, maybe a dual bottom rails, so you tend to have a single central rail on those on the frame jig. Now a lot of cafe racers, and certainly that use the Norton slimline or wide line frames, they're going to tend to have twin top tubes on the top of the frame. And so I've kind of gone with a style on this particular frame jig where I can get something up higher on those top two frame rails to keep them level, in line, and just basically address the positioning of those in space a little better. So that's the approach I've taken with this particular frame jig. I've seen some pictures online, and again the ones that I've done. So I'm doing a little bit of both, where I will mount a central rail, and we'll also have an elevated top section so we can keep the two top rails in line with each other and parallel. You'll see as we go. Okay, so let's do one more leg. Here is the heavy gauge bottom rail that I'm going to mount centrally in the jig, and this will be used primarily to keep the bottom frame rails aligned up, down, left and right. Okay. It also gives you a reference plane to mount engine tabs, gearbox tabs. Those can come up from the bottom frame rail just a few inches as needed to get the tabs mounted left and right, the proper distance, and up and down. One of the things you get into when you're making a frame jig is to try to keep everything level. So what I'm thinking about doing is using one of these threaded bosses at each corner, just with a simple bolt threaded in. I'll put a lock nut on this, and by placing that at each corner, again, what I'm thinking about is right here, just by welding it there, I'll be able to adjust the height using the bolt. Really simple way. And again, it's just really important to keep everything as level as possible when you're fabricating a frame. Set up on another corner here with the levelers, and again, I'm just using some threaded bosses that I happen to have. I'm trying to use as much stuff that I just have around to make the jig rather than going out and buying a bunch. I wouldn't normally use a chrome bolt, but I had some. To this one I've added a jam nut, a true jam nut, which is just a thinner nut, but what that allows you to do is have just a little bit more range of adjustment before you bottom out against the unthreaded part of the bolt up against the jam nut, which is used to lock this in place. Once you get it all level, you don't want things to move, so you put a jam nut on there. It'll end up like this. Let's see where we are. We're close, so I'll back it off again just to get it where we can tack it up with a blob or two. Okay. That'll give me enough to get a bite on right here and here on each side. That'll work. Let's do it. Have to be able to weld with either hand for the camera. Not that good. With the right hand. Here we go. So let's do this final corner. Okay, so we've got our corners welded, and one reason I like to use a standard hex nut on here is so from the top side we can adjust this using an open end wrench. And I've got the bubble here so you can see it. So we'll be able to dial this in just by turning the adjuster, watching the bubble for a level, try to get it dead center. We'll have to go to each corner, checking each corner again and again, but you can see I can get the bubble in the center, and I can go a little beyond. So let's come back, and then at that point we would lock the jam nut we stuck on there, and that'll keep it from moving in the heat of battle. Just snug it up, not going anywhere. But anyway, quick level technology. Okay, next thing we're going to do is mount this center rail to the outer ends of the frame jig. And so we want to make sure this is centered left to right. I've kind of got it roughed in. And I'm just using this square to kind of see how far out we go. And pretty close. A few times. I mean, it wouldn't hurt if this went to the left just a hair. Loosen my clamp and give it a couple of whacks. Whoops, probably too much. Now let's check it. Check it first. Actually, that's pretty close. So, just checking it a few times. You know that old saying, measure twice, cut once, yada yada. I find you have to measure like 5-10 times. You really can't measure too much, but twice, at least with metal, is not enough. You really can't measure enough. Always something. But again, this looks pretty good. And really, if you can find different ways to make the measurement, that's even better. Okay, I think we're ready to at least tack this base piece up. You know, we call it a tack, but it can be more. You know, you may want to do, for something like this, you may want to put about 1 inch of a bead down. But whatever you do, just understand that, you know, you may be back grinding it off or cutting through it to free it up because some measurement was wrong. So you don't want to put down more than you're willing to cut off. You're going to have to spend the time to cut it off to free it up if you make a mistake or something changes later, which is the way it happened. So we'll just put something on here to hold it secure. Alright. Pretty thick piece of 2x4 I put down here. It's going to take a bit of heat. That'll hold it. Okay. After getting this base plate, very heavy gauge, gosh, this thing is probably 1/4 inch thick. Very heavy gauge 2x4 piece. After getting that in place, I was just checking my sort of roughed in steering neck mount here. Whoops, it fell off. Steering neck mount here. And one thing you can do to kind of check alignment of things is to more or less take them to an extreme angle. So I've lowered the steering neck rod down with a piece of cheater bar that has the same 3/4 inch inside diameter as the steering neck that allowed me to take this down all the way to the base plate. So, you know, in theory, this should be lining up exactly on. I put some machinist ink down here and scribed 2 lines from either side to find the center. So that steering neck needs to be hitting in that center, not over here to the left. So that's going to allow me to line this up and to re-tack my steering column mount that I have up here, which I will do. I knew this was kind of a rough-in situation, and really this is a process of honing it to make it more and more accurate. So, you know, I found my center line here. I'll get it to where this tube basically mounts. There's a certain amount of slop in here, but once it's all welded down, it's going to be very tight. You know, I'll be able to have that outer edge just touch that center line so that when this goes back up, the steering neck will be synced and indexed to this base piece, which is going to attach the bottom frame rails, among other things, engine mount brackets, etc., etc. So this is just something I wanted to check as soon as possible before we get too far along and get this accurate. Once I get it fully adjusted, I will go ahead and re-weld the steering neck mounts up here, which you can see I've already cut those, so I can free this up to get the angle to match. Anyway, part of the process here of getting it as accurate as possible. Okay, so working on the steering neck column here on the jig, to address this potential misalignment, I have mounted a couple of clamps. Again, you can't have too many clamps, and it allows me to hold the mount down and use this clamp to adjust the fore and aft of this and pull the steering column, steering neck tube left or right. And we can go down here and see now that I've got this mounting point as shown on the ink here pretty much dead center with that. It's hard to see with the shadow, but it is very close. And again, by extending this steering neck mount using my cheater bar all the way down, that's a good 4 feet away from the pivot point all the way down there. And what that allows is, by exaggerating this length, you know, we're probably getting this down to an accuracy of 2 or 3 millimeters at this distance. So it's probably less than a degree of error when you get back up here to where the steering neck will be once it's all nailed down. And we'll continue to check this. I even have some lasers I use to position things, and it's a constant battle to maintain this accuracy, but we want to apply it any way we can. And again, by taking these distances out to an extreme length and then having to measure, you know, 1/16 of an inch or whatever, it just allows you to get your accuracy at the other end much closer. So we'll go ahead and tack this down again and move on. Okay, so let's put another tack here. Again, just a tack. We never know when we may have to tweak it again. This is as good as we can get it right now. Over here. take just a second here to clean up some of this metal. We have covered a lot of ground in a short amount of time on our frame jig. And you will notice that I have added something new here to the jig, and that is an old Norton vertical twin. In this case, it's a set of Atlas cases. I've got the transmission mount, sort of the rear bracket here, and some frame tabs. Just again to kind of start positioning this. Really the purpose of the frame jig is to make order out of chaos, to create something that has a relative position, in other words order, out of the chaos of emptiness out here. And by incorporating these pieces, these will help us to create that order and position things where they need to be for an easy bolt-in when it comes time to assemble the bike. The second thing that a frame jig should do is to allow repeatability. It's a big deal. If you're going to make more than one frame, you want it to be repeatable, and you want it to be repeatable in a very accurate way. So what we're going to use this transmission mount, engine cases, rear mounts, frame rails, we're going to use these to position all of the pieces, the tubes, tabs. I'm going to use this as a starter way. And some of you will notice here on the front, I have a Norton isolastic mount used to control the vibes of a parallel twin, and we're thinking about using this. We'll see, more to come, so stick around. But for now, as we say, please click the like and subscribe button, and we will be back soon with part 2 of this project.